Hey guys, Mr. Milton here. Today we're going to look at solving systems of inequalities notes. And at the end of this video, you should be able to find all solutions to a system of inequalities by graphing. Okay. So a solution to any equation or inequality in any order is any ordered pair that makes the equation, inequality, or system true. Okay. A solution to a system of equations is found at the intersection of two lines. Which is why there's only one solution. But when we deal with inequalities, a solution to a system of inequalities is found in a shaded or a region, there we go, let's say that, of the graph created by two lines, which is why there are infinitely many. Okay, so how many regions were created when we had one linear inequality yesterday? So you saw yesterday that we created one region. Okay, how many regions typically will be created when we have two linear inequalities? I think that's 4. And how many of those regions will represent solutions to the system of inequalities? Just 1. Okay, and so let's see that in practice here. So here we're given the system y is less than 1/2 x, and x is greater than or equal to 1. So I'll do this in those colors. Okay, so y is less than 1/2 x. Our y-intercept is at 0. 1/2 x is up 1 over 2, up 1 over 2, up 1 over 2, down 1 left 2, down 1 left 2, down 1 left 2. Okay. Okay. All right, and then it's less than, so we know our line should be dotted. Dot along here, and that's just a reminder for us really that the line is not a part of our solution. Okay. All right, bye-bye ruler. Here we go. Okay, and then as we think about shading, we would shade below. There's a couple ways that you can do this, but I'm going to just shade below here really sparsely so that I don't overpower what's going to happen next. Okay. And so now as I deal with the second line, I have x is greater than or equal to 1. Okay, this is that x equals kind of line, right? And so that's a vertical line at 1, places where x is 1, right, up down here. And it's or equal to, so it should be a solid line. All right, solid line there, up and down. Am I doing it right? There we go. All right, my ruler. And usually we say above or below, but this line's kind of different because it goes vertical. So we don't want to say above or below. Greater than would be to the right of the line. Okay, and so I'm going to use a different color so it's more visual here. Shade to the right of this line, kind of sparsely. Okay, and so the region that has both green and yellow in it is where my solutions are. Okay, and so actually I should have probably used blue, but anyway. And that is this region down here. So somewhere in here is where our solutions would be. Okay, now remember that our solutions can be anywhere on our solid line or in the shaded area. So one of the solutions, it's like 5, 0. 0.50 is over here, 1, 2, 3, 4, 5 in the shaded area. Another point could be 1, -4, right? Shaded area, solid line. These are 2 solutions. Not the only 2 solutions, but here are 2 solutions I've chosen. Number 2, we have y is less than or equal to x minus 2. Do that in this red. Okay, so x minus 2 right here. Y-intercept is -2. My slope is 1, so up 1 over 1. Positive slope goes up to the right. Okay. And it should be a solid line. Great. Okay, and so we got that. Shade, it's less than, so we'll shade below. Just do that really sparse. And okay, next line, we're going to want to put this in slope-intercept form. I'm going to add 4x to both sides. Gives me -2y is greater than or equal to 4x plus 2. Divide by -2. So y is less than or equal to -2x minus 1. My y-intercept is -1. Oops. I did it, but I want to make sure we talk about it. Remember, we divided by a negative number, so we have to flip the sign, right? So y-intercept is -1, slope is -2, so down 2 over 1, down 2 over 1, down 2 over 1. Okay, going this way now. All right. So this line should be solid because it's or equal to. All right. Less than needs to shade below. We shade below this line. Okay. And I can really say, okay, below and where the blue is, that's where my solution should be. And so in this little triangle is where my solutions are. Okay, and so I can write a couple solutions, -0, -6 be a solution, -2, -5 would be a solution. Again, they're more than that, but solutions are where those shaded areas are. Okay. All right, so here they're giving us a problem. 3x plus 4y is greater than or equal to -8. I'm going to solve for a y, get it in slope-intercept form. So y is greater than or equal to -3/4 x minus 2. Y-intercept is -2. Down 3, 1, 2, 3 over 1, 2, 3, 4. 1, 2, up 1, 2, 3 over 1, 2, 3, 4. Okay. Should be a solid line because it's or equal to. Okay, and then it's shaded above. And I'm going to be really sparse with that just so I can tell what I'm doing afterwards. All right, so here we have 6x minus 8y is greater than or equal to -16. So I'm going to subtract 6x from both sides. -8y is greater than -6x minus 16. Divide by -8. Okay, and that gives me y divided by a negative number. Have to flip the sign. That gives me 3/4 x plus 2. 1, 2. Okay, and then I'll go up 3, 1, 2, 3 over 1, 2, 3, 4. 1, 2, 3 over 1, 2, 3, 4. Okay. Solid line. All right, and then this should be shaded below. Okay, so below our solid line, above this red line, it looks like we have our solution set in this large area here. Below the blue, above the red, everything in this triangle. Is 5 2 a solution? 1, 2, 3, 4, 5. 1, 2, yes. So it says, solve the following system of inequalities and then answer the questions that follow. We have y is greater than 3 halves x plus 4. 1, 2, 3, 4. Okay. Up 3 over 2. Down 1, 2, 3 over 2. 1, 2, 3 over 2. 1, 2, 3 over 2. Okay, and that should be a dotted line. Dot, 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 dot. Okay. And we would shade above. Okay, so really sparse shade above. Okay. My second line, I want to put in slope-intercept form, so I'm going to subtract 6x from both sides, solve for y. Negative 4y is greater than negative 6x plus 8. Divide by negative 4. Because I divided by a negative number, I have to flip my sign. So y is 3 over 2x minus 2. Minus 2. Up 3 over 2. Up 3 over 2. Up 3 over 2. Down 3 over 2. All right. And our line. This line is going to be dotted. Dot, 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 dot. All right. You'll notice about these two lines, and then the shades below. Oops. Okay, and then it shades below. And so there is 1, 2, 3 regions created because the lines are parallel. And then it says how many of these regions represented solutions, and this none. Okay, because remember, solution happens only when our regions both intersected that spot. Okay, so is this always the case? No. It could have been that it was less than for the first line and greater than for the second line, and then we had one solution set. But in this case, it wasn't. Okay. All right, that should be it for that lesson. See ya.